Welcome to Lesson 1.4, Segment and Angle Bisectors. The objective of this lesson is to apply new vocabulary to determine the midpoint of a line segment, and later we'll use construction tools to copy a segment, copy an angle, bisect a segment, and bisect an angle. Let's start with some vocabulary. The midpoint of a segment is the point that divides or bisects a segment into two congruent segments. So in your handout, you have two lines that are blank. It is the midpoint is one of the vocabulary words, and bisects. To bisect means to cut something in two. Notice if we look here, segment AB has a midpoint of M, and it has been bisected into two congruent segments. So we say that M is the midpoint of AB, M is on AB, and we say AM, the length of AM, is equal to the length of MB. Notice the tick marks, they indicate equal measure. Another vocabulary word is a segment bisector. A segment bisector is anything that cuts that segment in half. So you can cut a segment in half with a segment, or with a ray, or with a line, and you can even cut it with a plane. So anything that intersects a segment at its midpoint is called the segment bisector. In this case, we have line CD, which is a bisector of segment AB. All right, so let's start with finding the midpoint. How do you find the middle of a segment? So now remember before when we talked about finding the length of a segment, what we did was took the two endpoints and we subtracted them. And we found the absolute value. So it didn't matter whether we subtracted 10 from 4 or 4 from 10. As long as we were taking the absolute value, we found the distance. All right, so if I want to find that middle point, when you think of finding the middle of something, most people think of finding the average. And that's what you're doing when you find the middle. You're finding the average of the two endpoints. So if an endpoint is 4 and an endpoint is 10, if we do 4 plus 10 and divide by 2, we've just found the average of 7. So that middle point right there, C, is 7. Okay, let's practice that. Okay, so let's practice finding some of these. The midpoint of AB, so we need to find the point A. The point A is at -4. I'm going to add to that B, and B is -1. Well, -4 plus -1 is -5 over 2. So the midpoint would be -2.5. And if I come here and I see -2.5, it would be right about there. And that makes sense. Okay, let's try the next one. AD. A and D. A is -4 plus D is 2 over 2. -4 plus 2 is -2 over 2 equals -1. So if I go here, then B is midpoint between A and D. Okay, let's try the next one. CF. C is 0 and F is 7. Add the two together and divide, and I get 7 over 2, which can be reduced to 3.5. Sorry about that. So if I look here between C and F, 3.5 is about the halfway point. And the last one, F and B. F and B. So B is -1 and F is 7 divided by 2. -1 plus 7 is 6 divided by 2 is 3. So if I look at F and B, so F and B, and the midpoint would be 3. Okay, so remember, just add together and divide by 2. All right. We're going to talk about angles now. We've got a little more vocabulary. An angle bisector is a ray that divides an angle into two adjacent angles, so that are congruent to each other. So if we look here, this ray CD, it divides angle ACB into two equal angles. That's called an angle bisector. Notice the arc marks, they indicate equal measure. So if you look here, the two red arc marks are the same. That tells me that those two angles are equal to each other. If I looked over here, these this doesn't indicate that there's a bisector because this angle here is different from this angle here. They have to be equal. All right, so let's do some practice. So QS, ray of QS, is the angle bisector of PQR. Find the two angle measures not given in the diagram. Okay, I'm going to stop and I'm going to do this on a piece of paper. I'll be right with you. Okay, so they just said that this is an angle bisector. So that means that this angle and this angle are the same measure. So if this is 40, then this must be 40. If these two both equal 40, then the big angle equals 80. So we're going to write that down. So we're going to write down the measure of angle, and what's this one? SQR equals, so the small one is equal to 40. And the measure of PQR is equal to 80. All right, let's look at the next one. This is showing you that the entire angle is equal to 64. So if this is equal to 64, then what's this small one and this small one? Well, they're equal to each other. They're the same. So if I take 64 and divide it by 2, I get 32. So then this must also be 32. And you're going to write this properly using the correct notation. So the measure of angle, so what's the first one? PQS equals 32, and the measure of angle SQR equals 32. Okay, you do the last one. There's one more less for you to do. Check with your partners and make sure you got the right answer. And then we're going to come down here and continue. So again, QS is the angle bisector of PQR. It says find the angle measure not given in the diagram. So there's two angle measures not given in the diagram. So I expected that you're going to find the other two and you're going to use the correct notation for this. And that's what I'm looking for when I look in your notes. Again, this one is showing you what the measure of the whole angle is. And yes, you can have a fraction for an angle. And same thing with this one. So what you're doing here is using the correct notation, and that's what I'm looking for in your notes. Okay, if you have questions, please ask me in class. All right. Last thing we're going to do is review congruence. So here, the instructions say, use the marks on the diagram to name the congruent segments and congruent angles. All right, so each one of these has a congruent set of sides or a congruent set of angles. So if I look at this, I know that this and this are the same measure. So I can say that AC, which is a side made up of a segment, is congruent to BC, a side made up of a segment. I have two angles that are congruent, this one and this one. And since there's no confusing them, there's no reason that I have to use three letters. I could use three letters, B, A, C, to describe this angle, but I don't have to because there's no confusing A. So I can say angle A is congruent to angle B, and that's fine. Okay, let's try this one. This one's a little different. Well, first let's start with, let's start with the sides. FG and DG are the same measure. So we use FG, and notice I put the line across the top because it's a segment that makes up that side, and DG. Okay, now we have two angles, this angle and this angle. Now, if I said to you angle G is congruent to angle G, that wouldn't make much sense. So this time we do have to use three letters to describe it. So I'm going to say angle, and I'm going to start here, FGE is congruent to, and I do DGE. Now, does it matter if I started with the EGF or EGD? No, it's the same angle. So it doesn't matter what order I write those down in. Okay, and the last one I want to go over with you because I want you to understand that this indicates a 90-degree angle. Now, we've mentioned it before, but this is a 90, and this is a 90. So if they're both 90-degree angles, then they're congruent. And again, we can't use the letter X to describe that angle, even though that vertex right there is X. We need 3 letters. So we're going to say that WXZ, so angle WXZ, which is this angle right here, is congruent to this one over here. And it doesn't matter which order I do them in as long as the X is in the middle. So I can say ZWY, they're congruent to each other. And then the last one is the 2 segments are congruent. So WX is congruent to XY. And I know that because of the 2 tick marks. Okay, so now what you're going to do is take some time and go do the practice for lesson 1.4 and have a good afternoon.